the graph of a function. You can first sketch the bottom. So if I just sketch the bottom, y equals x minus 3. This is a straight line. I know that it has a y-intercept of minus 3, a slope of 1, so I can figure out other points. And this blue graph is the graph of y equals x minus 3. Then right beside it, in green, I'm going to sketch the reciprocal. And the reason why it's nice to graph the original one first is you can get a lot of points off the original one. And the rule for the reciprocal is all that you're doing is your y value is changing to be 1 over the y value it was before. So for example, you would have a point like 0, negative 3. And on your reciprocal graph, the basic rule says whatever point you had on your original graph, you have 1 over that point on your reciprocal, which is pretty obvious that if I plugged in 0, just like a table of values into the green equation, I would get 1 over negative 3. Now, the interesting thing about reciprocal graphs is that some places you have non-permissible values. For example, on the blue graph, I have the point 3, 0. When x is 3, what happens on the green graph? You get a non-permissible value. And non-permissible values show up as vertical asymptotes. At least that's how they'll show up for everything we do in grade 11. In grade 12, sometimes you get holes in your graph. But we're not going to get there this year. This year, they will always become vertical asymptotes. And we already talked about how if the original graph goes up forever, and in all of our examples it will do that, you will have a horizontal asymptote at y equals 0. Next, to finish your graph, all you have to do is get enough points to feel comfortable drawing your graph towards your asymptotes. Usually, that's going to be 1 point in each section of its domain. And the domain is going to be split up by this asymptote. So we're going to have, and I'll just write it out underneath here, we have one section left of the asymptote and a second section right of the asymptote. And your graph is going to go towards these asymptotes. So technically, having this y-intercept is enough to draw your graph in this section. It's got to go towards the asymptote there. It has to go down towards the asymptote there. It can't go up towards the asymptote because reciprocal graphs have no x-intercepts. But we could have done another point. For example, like in my line, I could plug in 2, and I would get negative 1. So I would have, we'll just pretend my graph went nicely through that point. I would have the point 2 and 1 over negative 1. Ooh, because it stays the same, right? It would stay negative 1. So I have enough in this section, section number 1, to draw my graph towards the asymptote. Notice I have no points yet in section number 2. So if I go back to my original one, I could plug in 4. And what happens when I plug in 4? I get 4, 1. When I go to my green graph, that would mean I would get 4, 1 over 1, which is still 1. Ooh. And then that would be enough to say this section has to look like this. Part B of this question is asking for your domain and range of your green graph. And the easiest way to write the domain is just to say, well, x can't equal 3. It would be fine if you wrote it like that. If you'd like to say x can equal all the other things, sometimes you'll see in textbooks, they put a comma and say x can equal everything else, but you have the one restriction that x can't equal 3. Okay? Same thing with your range. Y can't equal 0. That would be enough to say the answer for the range. Questions for practice on this one are 6 and 7.